In this and the next few videos, let's analyze a function. The polynomial p of x equals x to the fourth minus 4x cubed plus 10. In this video, we'll analyze it using the first derivative. We'll find when it's increasing and when it's decreasing. And we'll find and classify its local extrema. And to do both of these things, we should start by finding the critical values. Critical values come from the first derivative. There would be a critical value anywhere this derivative doesn't exist. We don't get any critical values that way. A cubic polynomial is always defined. We might get some critical values by setting this equal to 0. We see there are two critical values. They might not be local extrema. We have to classify them. But the derivative equals 0 at 0 and at 3. And I'm going to classify them using the first derivative test. And to classify local extrema, we're using the first derivative. So we mark down 0, we mark down 3. Select a point between 0 and 3. Any point will do, let's say 1. If we plug 1 into the derivative, we get 4 minus 12, or negative 8. And the 1 doesn't matter. And this doesn't really matter either. The only thing that matters is that about the 1 is that it's between these values. The only thing that matters about the negative 8 is that it's negative. Pick a value out here. Again, it doesn't really matter what. Say 5. Stick 5 into the derivative. We could go to a calculator if we needed to, but let's see, 5 squared is 25, times 4 is 100, times 2 is 200. Again, the detail doesn't matter. What matters is that it's positive. And if we go over here and select something, -1, let's say, -1 squared is 1 times 4. -1 minus 3 is -4. This product is negative, a positive number times a negative number. And there's our sign chart. And to answer our questions, this function is decreasing when the derivative is negative and increasing when the derivative is positive. And 0 does not represent either a local minimum or a local maximum, but we have a local minimum here. A local min at 3, plug 3 in here. I did so, and I got to this as our local minimum. We will now investigate this same polynomial in terms of its concavity. However, I say we'll now do that. We'll do it in its own video.